Hello and welcome back to the channel. Today we're going to be looking at how to install Windows 11 on a Raspberry Pi 4 8GB model. The objective was to make a low power, low cost mobile device with waterfall band scope so that it would make it easier when frequency scanning. The Raspberry Pi 4 is an ideal candidate. There are a bewildering array of enclosures and cases. Screens, batteries, you name it, they do it for the Raspberry Pi. So in the later videos, which will be coming soon, we will be focusing on the Raspberry Pi operating system, which is based on Linux. This video may be of use if you want to install Windows 11 on the Raspberry Pi 4. We were unable to get the RTL SDR radio dongle to work with Windows on ARM. However, we did manage to get it working absolutely flawlessly on the Raspberry Pi OS, which is Linux based. However, that is for another video. So let's crack on and have a look at how to install Windows 11 on an ARM based Raspberry Pi 4. You will need the Windows 11 ARM 64-bit ISO file, which is an optical disk image of the Windows installation media. If you search online, you are directed to the Windows Insider program and requested to sign up. However, doing so resulted in being offered a download of a VHDX file, which is a virtual hard disk for running on Windows Hyper-V. In order to obtain an appropriate ISO file, head on over to the uupdump.net website. Congratulations to the person who thought that was a good name. So let's take a let's take a look at the ISO creation using UUPDump's website. Enter Windows 11 ARM in the Search for Builds box and click the search button. You will then be presented with many builds from the Insider preview. Generally, I pick the highest version in the list, or the first version, which has the most recent date added. In this instance, it's the 22543 version, which was added on the 27th of January 2022. So click on this item to proceed. You will now be guided through a process for downloading a program which enables you to create the ISO image. Select your appropriate language and click Next. I leave both editions selected and click Next. Download and convert to ISO, which is the image we're after, and you can select any additional options you want here. Now you click on Create Download Package. This will offer to save a file to your computer, which will contain the program needed to download the files and create the ISO image. So I'm going to save this to my machine. Once your download has completed, we can exit this website and we can go and run that process. We now need to extract the contents of the downloaded file. Head on over to your Downloads folder and right-click on the compressed zip file. Use your decompression software of choice, I am using 7-zip here, to extract to disk. Various files and folders will appear. The one you're interested in is the UUP download windows.cmd file. This will run a set of commands to download and build the ISO file. So double click on the file. This process may take some time. once the process has completed, press 0 to exit. So once the process has completed, there are all sorts of files in the folder, but this is the one that you're after, the ISO file. So you can select and delete the remaining files and retain this ISO image. The next component you're going to need is the Windows on Raspberry Imager application. Head on over to the WOR project website. Next, click on the Downloads page. This application supports Raspberry Pis version 2, 3, 4 and 400. The latest version at the time of the recording of this video is 2.2.3, so go ahead and download this file. Further down the page, there is a boot partition mount utility. Download this as well. I am using a 128GB SanDisk Extreme Pro Micro SDXC card. This is a Class 10 V30 UHS Speed Class 3 device, which is rated at up to 170 megabits a second for reading and 90 megabits per second for writing. The next step is to extract the imager, so right-click on the WOR Release 2.2.3 file or the version that you downloaded and extract the contents. Next, run the WOR.exe file. Select your language and click Next. Select the device that you wish to write the information to. I'm going to pick the SDXC card in disk 4. Any information that exists on the memory card will be wiped when this process runs, so do ensure that any contents that you require you have backed up. Now select the appropriate Pi device. Mine is a Pi 4 8GB model. You will get a warning. Say OK. Click Next. Next you need to select the image file that you created earlier. So browse, select the image file, and I'll just make this a little larger, and you can see that this is the ISO file that we created in the process earlier. Say OK. That will inspect the image file. You can select the version of Windows that you want to use. We downloaded both, so you can select Pro or Home, and then click Next. I'd recommend that you select the most recent drivers that are on the server and say Accept. All of the hard work has been done for you here in ensuring that the most appropriate drivers are present. Click Next. And I'd take the same option for the UEFI firmware. I'd leave everything here as default and click Next. This will give you a page with an overview of what is going to take place and the selections that you've made. Next, click Install. This will now write the image to the SD card. The memory card now contains the Windows 11 image. Click Finish. The next thing we need to do, if you want to put a mild overclock on the Pi, then we need to use the boot mounter to mount the drive and edit the config file. Now that process is complete, we can have a brief tidy up of the items. And the next step is to extract these files to your computer. Once extracted, run the WOR boot mounter.exe, and this will bring up this tool. Click on the drop down, select your SD card or SSD, whatever you've used. Click on the mount option. This will mount that drive to your computer. This enables you to access the appropriate file, which is this, the config.txt file. If you edit that in your favorite text editor, and I'm using Notepad++ here, you can then add in to the bottom your appropriate overclock commands. I have a passively cooled Pi 4, which is in a metal enclosure that acts as a heatsink. I therefore cannot push the overclock to the extremes, so have elected to go for a safe configuration. I'm increasing the processor frequency to 1.85 GHz, the GPU frequency to 650, and applying an overvoltage of 4 to compensate. Next, click Save to save the file. You can close Notepad++, return back to your partition mounter, and click the Unmount button. This will take a moment. And that's it. You are now ready to boot your Pi. So let's take a look at the setup that we're going to use today. This is the Raspberry Pi 4 8GB model. We're going to power it via the USB-C connector here. We have the SD card inserted in the rear, which contains the Windows 11 image. This is a aluminium case which acts as a passive heatsink. There are no fans within this case, hence we can't push the overclock too hard. A quick word of warning on power supplies. The Raspberry Pi power supply should be a 3 amp 15 watt unit. A lot of the power supplies that you can plug a USB cable into do not output 3 amps, so please double check, especially if you're overclocking, that you have the appropriate power going in. And you can also get and buy these from Amazon, which are USB-C male to female. You can then use the button here to turn on and off your power, and that's incredibly useful if you're booting a Pi a lot, rather than having to keep pulling the cable in and out to boot the device up. So very useful piece of equipment there. Conventional keyboard and mouse cabled, and I'm using a micro HDMI cable to full-size HDMI cable to output to the portable monitor here. Now this isn't the complete setup, because I need to insert a capture card in here as well, which will add a bit of further complication, but essentially this is all you would need to get this Pi up and running. So everything's plugged together, the Raspberry Pi has been turned on, the power LED is showing at the back, the Raspberry Pi is at the boot screen, and we're now ready to move on to the next stage. There are some essential configuration items that you need to do. When the machine is booting, hit the escape key and you will then enter the BIOS as shown on the screen now. The first option, Device Manager, you need to enter here, then go to Raspberry Pi Configuration, Advanced Configuration, and this option, Limit RAM to 3 GB, needs to be disabled. This option is enabled by default. You hit the Enter key and you can select your appropriate option. Disabled is the one that you want. Hit Escape, Escape again, and Escape again to return to the main menu. Another option that can be useful is the Boot Maintenance Manager. If you come in here, go to Boot Options, change Boot Order, and then in this list, if you hit Enter, it will display the list of devices that are checked in the boot order when the machine starts. Having the SD/MMC as the first item should speed up the booting a little, so it's not checking other devices. Return back to the main screen by pushing the Escape key and then take the Continue option to save changes and restart the machine. Now that we've booted into Windows, we can check to see if the memory change in the BIOS has taken effect. So we can go to Task Manager, and then if we have a look at performance, you can see that the memory is 1.9 out of 7.8 at the moment, so Windows is using the full 8 GB that's available on the Pi, where previously, without the registry change, it would not be using that memory. Undertaking a YouTube video playback test? Well, it's not great. In auto mode, YouTube is selecting 720p as the most appropriate setting. It works fine, but we are experiencing quite a few drop frames. Dropping the quality down to 480p does improve things quite a bit, but you can't expect this type of setup to be playing back 4K content seamlessly. Looking at benchmarking, I couldn't get Geekbench to run, it kept failing, but Performance Test ran, pass mark, giving us a total score of 282, which is absolutely terrible. The world average is 4,163, and this is scoring 282. I'll just run through the relevant tests here. CPU mark, 2D mark, a 3D mark didn't run. It had some issues with DirectX because it's not supported on the ARM version of Windows. Memory mark did okay, and disk mark was equally as terrible. The benchmarks in this video were to highlight the performance you can expect from a Raspberry Pi 4. You'd be much better off for portable use using a mid-tier, mid-range Core i5 laptop of any flavour. I much prefer Windows over Linux. I just find it's easier to use and it's more friendly, and usually more things run on it, but in this example it's the other way around. A special thank you to the creators of the UUP Dump website and the WOR project for providing excellent and easy to use tools. The community thanks you. Now that's it for this video. Please keep your eyes out for the next instalments, where we'll be looking at SDR radio running on the Raspberry Pi using the Pi OS. If you found this video helpful, please like and please subscribe. It really does help out my channel. Until next time, see you soon. So, in conclusion, is Windows 11 on the Raspberry Pi any good? No, it's shite.